Hi everyone, welcome back to another Edpuzzle lesson. Remember, when you see a pencil logo, please write the stuff down in your notebook. So let's get started. Today's FLT is here. Given an equation, I will be able to solve for x by using inverse operations on both sides to isolate the x. Remember, our goal is to make x by itself. And we do this by doing opposites, so inverse operations on both sides to keep that balance. Alright, so let's say I had an unknown amount of money, and after I doubled that, I have now a total of $6. How much money did I have to begin with? I probably had $3 to begin with, because when I double $3, it equals $6. But let's make that into a math equation to make sure. So I'm going to set it up as 2 times x equals 6. So that x represents the unknown amount. And since the multiplication symbol that we can write as kind of like an invisible sign, we'll just write 2x equals 6. So whenever you see something like 2x, that just means 2 times x. We're just making that product dot invisible. So this is going to be our first example. Solve for x when 2x equals 6. Alright, so I have 2x equals 6. That's the same thing as 2 times x equals 6. So I want to somehow get rid of that 2 that's right in front of the x. So think about what is the opposite of multiplication? Division. So we are going to divide by 2 on both sides. Remember, we're doing inverse operations on both sides to balance that equation. We want to keep it balanced. So on the left side, the 2's cancel out, so we're left with x. And on the right side, 6 divided by 2 equals 3. So right here, the canceling out process, notice that 2 divided by 2 equals 1. So there's technically an invisible 1 right here. But we don't have to necessarily write it, because think about like, oh, I have $1 versus I have a dollar. That's the same thing. So same thing with the x. I have 1x, or I have ax, annex, ax, same thing. And so we get that our answer is x equals 3. Let's take a look at another example. So solve for x if 3x equals 21. So we have 3x equals 21. So 3 times x equals 21. And how do I remove that 3? I'm going to do inverse operations on both sides. So I am going to divide by 3 on both sides. So the 3's cancel out, so I'm left with an x on the left side, and on the right side, 21 divided by 3 equals 7. So x equals 7. And again, there is that invisible 1 in front of the x, because 3 divided by 3 equals 1, but technically it's there, but we don't really have to write it. So our answer is x equals 7. Our next example is on Edpuzzle. So solve for x if 5x equals 25. So before we move on, this is just like a little side snippet. And I don't know if it's true, but I heard that like this division sign is basically like a fraction just with unknown numbers. So that's why we write the division sign like this. That's what I heard, but I'm not sure if it's true. So like the unknown numbers, for example, like 16 over 4 equals 4, or we just write it using the division symbol, like 16 divided by 4 equals 4. So just a little snippet before we move on to the next part. Okay, so back to like a money example. Let's say there was an unknown amount of money, but you had to split it among two people equally, so splitting it in half. And so now you get $4. So how much money did we start with? So we probably started with $8, because if you split that into half, you're left with $4 each. But let's make it into a math equation to make sure. So we have an unknown divided by 2 equals $4. So x divided by 2 equals 4. Or I can write it as x over 2 equals 4. Same idea. So I'm going to make this the first example. Solve for x when x over 2 equals 4, or x divided by 2 equals 4. Okay, so think about how to get rid of that divided by 2 that's on the left side. So the inverse operation is to multiply by 2 on both sides. So on the left side, the 2's cancel out, so we're left with x on the left side equals 4 times 2 is 8. So we get that x equals 8. So let's say I write it as x divided by 2 equals 4. Same thing, just written differently. I multiply by 2 on both sides, and so that 2 on the left side is removed, and I'm left with x equals 8, because 4 times 2 equals 8. So same thing, just written differently. So in our next example, let's solve for x if x over 4 equals 6. So x over 4, or x divided by 4, equals 6. Alright, so I want to get rid of the dividing by 4 on the left side, because again, I want x by itself. So the opposite of dividing by 4 is multiplying by 4. So I'll multiply by 4 on both sides. So then I can get rid of the 4. On the left side, I am left with x, and that equals 6 times 4, which equals 24. So I get that x equals 24. And lastly, on Edpuzzle, please solve for x when x over 3 equals 9. So when x divided by 3 equals 9, what is x? So just a quick review. Today we used multiplication and division as inverse operations, and we used it on both sides of an equation to isolate the x. So again, we used inverse operations on both sides to solve for x. Be sure to submit your notes on Canvas, and see you next time.